Studying circles, or roses of one petal, gives us a nice segue into roses of more than one petal. If I am going to talk about roses, I'm thinking to myself, they have one term. In other words, they're not split halfway with a plus or minus sign. Oh, we might have a plus or minus sign out in front, but in the middle, this is A times cosine of B times theta. There's no plus or minus within the meat of this. So remember, anytime you see cosine, you're thinking polar axis symmetry, at least. And anytime you see sine, you're thinking theta equals pi over 2 symmetry, at least. For all of these, B is the number of petals, and A is petal length. That's for both plus or minus A cosine B theta, and R equals plus or minus A sine B theta. This isn't the full story because it's going to depend if B is odd or even. I could say B is the number of petals provided B is odd. So let's look at when B is odd first. So if we're going to talk about plus, do I have to write that? No. Plus A cosine B theta, where B is the number of petals provided B is odd. So let's look at when B is odd. Of course, A is always going to be petal length. All right, so let's start with R equals, I'm going to hold petal length equal to 5. There's nothing magic about 5. Cosine of 1 theta. Oh, we've already seen that, haven't we? We know that this is a circle or a rose of one petal, and we saw that this will be 5, 0. That's R theta, that's not XY. And we have this polar axis symmetry. Whatever happens above happens below. We go through the pole, which is 0, 0. Again, that's not XY, that's R theta. And everything is pointing to the right of what of this theta equals pi over 2 vertical axis here. All right, so we know this. Look, it's pointing to the right. Number of petals equals 1. Let's up the ante a little bit and put number of petals at 3. Well, it's still an odd number, so I know that the number of petals will be 3. I'm not going to do this often, but I'm going to make one theta r choice here. If I put in, now we're going to take whatever our angle is, multiply by 3, and then take the cosine of that. So if I substitute in 0 for my angle, I get r is equal to 5 cosine of 3 times 0. Remember, PEMDAS requires us to do parentheses first. 3 times 0 is 0. Cosine 0 is 1. If you know your unit circle, times 5 is 5. So why did I do that? Because I wanted to make sure I had this point 5, 0. And that's not XY, that's R theta. And so here is one petal. Now, I have 360 degrees to play with, and I've got 3 petals. So there's going to be 120 degrees between petals. So at 2 pi over 3 here, I know, what did I do here? I went 120 degrees, or 2 pi over 3, and this would be a negative 120 degrees. Or I could say that if I went all the way to here, that would be 240. So that these have a maximum angle between them. If I'm talking about like the spine, if this is actually a flower, that would be the vein in the middle of the flower. Notice what cosine does. It's still, if we think of this as a little, it's not a starfish, is it? A little flower. The head is pointing to the right. You're going to find that with cosine all of the time. For a positive cosine, the head is pointing to the right. If we put a negative here, then this whole thing would flip around. What do I mean by that? If I put a negative here, well, if I do this theta r technique and I put in a pi, for example, here, then I'll have negative 5 cosine of 3 pi. Cosine of 3 pi is -1 times -5 is 5. So notice what I have here. I've got this point, a directed distance of 5 at an angle of pi. So here is one of my petals. And then of course, if I'm going 120 degrees or 2 pi over 3, it's going to look like that. Remember, the positive cosine of the positive 5 cosine 3 theta was pointing to the right. If we put a negative, again, we've seen this before, it's going to reflect over this theta equals pi over 2 axis. Also notice, because we have cosine, we have at least this polar axis symmetry, and you can see whatever's happening above the polar axis is mirrored below the polar axis. Graph 5 cosine 5 theta. Notice again, I'm holding petal length equal to 5. Well, this is odd, so I know that the B here represents number of petals. And I know that's going to be 5. Well, I don't do this often, theta and r, but only if I'm confused. What if I put a 0 in for theta? Well, this would be, r would be equal to 5 cosine of 5 times 0. 5 times 0 is 0, cosine 0 is 1 times 5, so I get this. Oh yeah. So I'm looking here and saying it's going to look like this. Here is that point again, 5 comma 0. That's r comma theta. Well, I've got 360 degrees to play with, and I want 5 petals. So they're going to be 72 degrees apart. Well, to go to the positive and negative theta equals pi over 2 axis, that's 90 degrees. So just shy of that, but sort of in quadrants 1 and 4, we're going to have the 2 arms. If you consider this the head pointing to the right, we'll have 2 arms there and then 2 more down here. So it's going to look like that. It's got its head to the right of the of the theta equals pi over 2 axis, and then 2 arms are going to be above that because I'm going to the next petal. I'm going 72 degrees. Notice if I went 90 degrees, I'd be at this theta equals pi over 2 axis. So I know I'm going to have 2 more right here and here, and then I just went another 72 degrees and another 72, and then of course there'd be 72 between those 2 as well. So the head for a positive cosine, the head, or that odd one out, looks like the head of a starfish to me, is going to be to the right still, and we have this polar axis symmetry. Whatever happens above the polar axis happens below the polar axis. This is what I'm talking about, that polar axis there. What if I change this positive out here to negative? I still know it's a five-fingered or 5-legged starfish with 1 being a head. So if I put in theta and r, and again, I don't do this often, especially after I know what these look like, but if I just wanted to test, if I say, well, what if the angle is pi? Then we'd have -5 cosine of 5 pi. Well, cosine of 5 pi, it's an odd number pi. It's -1 times -5 is 5. So what does that tell me? Well, I have this point here, right? This is our point, r theta, 5 comma pi. And if I know I'm still dealing with 360 divided by 5 petals is 72 degrees between each petal, now my petals will be to the left of the theta equals pi over 2 axis, and then I'd have 2 more over here. In other words, what I've done with that last shape, I've just flipped it or reflected it over this theta equals pi over 2 axis. So the head, or the odd one out, I always call that the head, that's pointing to the left now because I had a -1. But the positive cosines always have the head pointing to the right over here, as we've seen. Well, 1 term, and I held the petal length constant at 5, and B of our formula here is odd. So I know there are 7 petals. Well, what if I chose 0 and r, theta and r, and I chose 0 for theta? I'd have 5 cosine of 7 times 0. Now, I have to do in parentheses first, so I could put a parentheses around this. 7 times 0 is 0. Cosine of 0 is 1 times 5 is 5. So why do I do that? Just to remind myself, here is our head, if you will, at 5 comma 0. Now, that's not xy, that's r comma theta. And if I have 360 degrees to play with, and I'm dividing it by 7 petals now, because that's what B is in this formula, I get about 51 degrees. Notice if I go from this petal up, that'd be 90 degrees, and in this direction, I'd be negative 90 degrees. So 51 is about right there and there. So if I do another 51, of course, that'd be 102 degrees, and there and there. And then another 50 would be around there and there. And again, what am I doing there? Look, I've got a 1, 2, 3 petals, sort of like the head and 2 arms to the right of this theta equals pi over 2 axis. And the other ones will be on the other side here. Again, we've got polar axis symmetry, at least. Why? Because we're talking about cosine. The only thing I've done here is put a negative there. Well, don't believe me? Then do this. Now, do I actually do this? I don't. But if I chose pi now, I have r as negative 5 cosine of 7 pi. And I know 7 pi is an odd number of pi, so cosine 7 pi is negative 1 times negative 5 is 5. Why do I do that? I just wanted to check where my head was. Check where my head is. So here is this point, r theta, 5 comma pi. And again, I've got 360 divided by 7 is about 51 degrees. So that means here and here for my little arms, and then I'll have 1, 2, and 3, 4. Notice in between each of these is about 51 degrees. Maybe my diagram isn't so great, but I'm trying to show 51 degrees in between the spines, if I was going to add the spines of each of these flower petals. This is 7. I'm going to stop there, but we could keep on going. If I change this to 5 cosine 9 theta, plus or minus, the plus would have the head here and the minus would have the head here, and we have 9 petals with 360 degrees divided by 9 between each petal, etc., 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 etc. That's what happens when B, the number of petals, is odd. Fairly predictable.